Okay, the first surfaces you remember, if you remember, was copper wire. The surfaces of the copper wire were aluminum foil. The following thereafter, the surfaces of copper wire and aluminum foil that's in here that this is constructed with. The following foundation is iron wire. The iron wire is spun around the aluminum. The aluminum exhibiting this type of wire, which is AWG, I believe this is 14, and gauge wire, copper. And the following after that is aluminum foil. And the following after that is permanent magnets. Permanent magnets alongside the base. And the following behind that is tape, plastic tape, and the following behind that is a battery. What I did was I took apart the battery and scrolled it out into the battery like this, and scrolled it out into a circular around the aluminum. And I placed the metal bond cathode facing this way and the anode facing this way for the external. And then I covered it with plastic, and then I followed it up with adding more wire coupled to the battery that I banded around the base. And I also put aluminum, separate aluminum tape, adhesive tape, around the base that are separate from one another. I'm having lamination and plastic tape, and that's around the base. And I have another set of coils under there, right under there, and spun over. I unify these with capacitors, so I have two coils here that are alongside one another. That's what makes the capacitor for this side and the capacitor for this side. Then I have another for the ends, the phase wire in, is the capacitor for this side and the capacitor for this side. So what I did was I used the positive for the Lenz's law. I used the positive side of the capacitor output to phase both ends. So this is parallel to the end of the windings. So the Helios coil, let's start from the inside because there's three. The Helios coil phases the power output of the capacitor at both ends, and the capacitor both ends are, see right here, it is, the positive is bypassed with a wire, so that this may also, when I switch it, become an anode, so that the wire that phases the input will also convert this to an anode in, and a positive from positive to anode in, depending on the switch of the voltage, whereby I induce the currents at either end. So this is the central, the whole fact I plan to add more coils from copper to aluminum to copper to aluminum and copper to aluminum foil. I'm going to use a step-up gorge of aluminum sheets and copper sheets just to get the densified viscosity increases. How can I say, densified longitudinal force, because it's to act as a pusher and actuator to actuate it. So I need something dense to move up to cause a jerking force or drag force of this inertial mass. So here, excuse me, here is the capacitor that phases the internal part. So I have a tape right here to phase the aluminum so that the aluminum have conductivity, and besides the coils receiving conductivity. So this is like a voice cord that has permanent magnets that's coupled to it, and capacitors also that is coupled to its inertial mass. The capacitors are rated at 450 volts. There are 1, 2, 3, 4 capacitors that are going one way, and on this side there are 4 capacitors that are going one way. 1, 2, 3, 4. Okay, and there's one capacitor that is actually phasing this for 450 watts. Right, and I'm going to add another capacitor to increase the 450 watt drawer into storage into 900 watts, 900 volts. So I intend to add another capacitor there. I'm going to drive this by acoustic transducer driver just to get it to flow. And all the bipolar, as far as the Lenz's law, diverse drive using eddy currents from Bittler induction to cause the windings to be pulled and pushed, so in a sense to force this object itself into the air. It should not have to kick on any densified mass, but itself, the flux against itself, and to try to expand, and because of the expansion moves in a linear measure to force it to go upward into the air. Excuse me. My name is Jermaine Morton, and goodbye. Okay, so what I did was I applied the battery. I took this, I cut it open along the side, then I unfolded it and applied it within here around the base. So it's underneath the foil, and I took the 2 strips and I folded out around underneath here. There is 2, 4, 6, 7 capacitors. One is to phase the battery. I just showed you the 2 phase points, so I unfolded it. One is to phase the battery, and one is to phase out here on the external. I have it covered with tape. The battery is then phased with a capacitor on the output, and then I have the capacitor line, one of the metal bonds. There's permanent magnets alongside the base. That is underneath the power battery. There is also coil, or Helios coil. There is also iron wire. This is also magnetic. We do have permanent magnet within it. So right here, that permanent magnet is in it, but because of the magnet blocking, as far as the foil, make it a little bit hard to stick, so it loses its repel force through the viscosity and the thickness of the magnet microwave blocker. So where it has less strength for the permanent magnet and the electromagnetism. Now it has more strength out here around the diameter, perimeter of the sides, as you can see, and but the magnet inside of here is more blocking and don't want to stick that well. So just to try to hold it there for a few seconds, and hopefully it sticks, or it fall down, pull it up a little bit higher, and pull it up higher still, and it falls even when close to the wall. So the magnet blocking right there mechanism is doing good. I tend to plan to add a voltage to it, which will synchronize the battery, which will be an automatic battery and an automatic voltage for here. However, I still have to cover this in 2 portions with rubber and with aluminum. So I'm going to close the gap with more copper, and I think I'm going to transform it into a sphere to see what that, how it may turn out to. So I have the Winslow phase wire in. I told you about that already. I have it on here because I'm matching the color, matching the phase wires to each one, to the Winslow. And then I'm just going to test it and see what I get out of it. And I already tried my voltmeter. I'm waiting for that battery to die so I can add it onto it in the inside using these things in the chain. So I checked my voltmeter and it was 3.8 volts, and that's like, wow, that's like fully charged for 3.8. And it's rated at 3.7 right there. See that? So I was wondering why the heck it shows up 3.8. So I was like, wow. So I gotta try to die it out to diffuse it before I unravel it and take it apart and apply it inside. And then restart it again through synchronization. My name is Jermaine Martin, and I'll be back with this new AV, electromagnetic drone, self-repulsive.